Combining functions. There are a few ways to combine functions. F plus g of x. That is new. You've probably never seen this before. And if you have, there was a point where you never saw it. So we write 3 lines. That means what we just wrote is defined to be f of x plus g of x. Just add the 2 functions. Nothing major there. So if I tell you that f of x is 3x squared plus 4 and that g of x is 7x cubed plus 9x, and you are asked to find f plus g of x, just add them. This is f of x plus g of x. And there are no like terms. How do I know? Because these are the terms. And if I ignore the number here, that term is an x squared. If I ignore the number, that's an x cubed. If I ignore a number, that's an x. And this is just a number. None of these are the same. They're all different. So that problem is done. If I were to tell you that f of x is 3x, if I were to tell you that f of x is 3x squared plus 7x plus 9, and g of x is 4x squared minus 2x minus 3, and I ask you to find f plus g of x, it's really simple. F plus g of x is f of x plus g of x. And those are x squares. There are 7x squares. These are x's. We have 5 of them. And the constant is 6. And that's the answer. Just add the 2 functions. Very simple. Now, what if you have f minus g of x? What does that mean? Well, again, it's simple. It's f of x minus g of x. So if I give you f of x and g of x, you should be able to figure it out. If f of x is 3x squared minus 7x plus 4, and g of x is 3x plus 4x squared minus 11, and the instructions are to find f minus g of x, well, it's just f of x minus g of x. So how many x squares do I have? The answer is negative 1. 3 minus 4 is negative 1. How many x's do I have? Negative 7 minus 3, that's minus 10. What's the constant? 4 minus negative 11, which is 15. That was harder than the first step. You just write down f of x, a minus sign, and then g of x. Don't get that wrong. I wrote down f of x plus g of x, because that's what they asked me to write. if they wrote it the other way, g minus f of x, well then it's g of x minus f of x. Since I quote did it backwards up here, I will get negative x squared minus 10x plus 15, which is plus x squared plus 10x minus 15. Think about that. Yeah? If you do 7 minus 4, you get 3. If you do 3 minus 7, you don't get 3, you get negative 3. You got negative that answer. Okay, and that's what I did. I took that answer and I took negative that answer. That gave me what g minus f was, knowing that f minus g was right in front of me. Okay. Give you some more definitions. None of them are hard except maybe the last one. So you have f times g. Now, that is not a circle. It is just a dot. This is f of x times g of x. If f of x is, I don't know, 3x squared minus 7x plus 11, and g of x is 2x minus 9, then f times g of x is equal to f of x times g of x. If you want, you can distribute. That product there will be 6x cubed minus 14x squared plus 63x plus 22x's. I'll put them under the other x's, minus 99. 6x cubed minus 14x plus 85x minus 99. So multiplication is nothing new. Just know that f dot g means f of x times g of x. The last one, before the harder one, f over g of x is equal to f of x over g of x, where the bottom is not 0. It's something other than 0. So, for example, if f of x was 3x squared plus 4, and g of x is 7x cubed plus 9x, then f over g of x, well, it's defined to be f of x over g of x. And you can take f over g of a number that would make the bottom 0. So division is not special. Whatever I put here and whatever I put there, if they say f over g, you put the f function over the g function. Now, let's talk about domains. Let's talk about the domain. Suppose that f of x is 1 over 2x and g of x is equal to 3x squared plus 4x minus 1 over 2x. And I ask you to find the domain of f plus g. Find the domain of f plus g. Okay, which I'll denote by df plus g. Find the domain. Now, if you add these together, if you do f plus g of x is equal to f of x plus g of x, and you cancel, you get 3x squared plus 4x. Now, the domain is, what x values can I put in here? Well, let's think. What x values can I put in here? Can you square any number? And there's three types of numbers. Negative numbers, the number 0, and positive numbers. You can square any number. That is multiply a number by itself. There's no numbers that you can't multiply by itself. You may say, well, I can't multiply 1 over 0 by itself. Fair enough, but that's not a number. That's nonsense. 1 over 0 is not a number. Because if it is, I'll ask you what number it is. Okay, you can multiply any real number by itself 2 times. You know what? You can then take that result and multiply it by 3. And then you can take that any number and multiply it by 4 and get a real number. And then you can add them. There is no restriction to what you can put in here for x. But that's not how you do it. Don't look to find the domain. Don't look at what you get after you simplify this. Do not look at the end. By definition, f plus g of x is f of x plus g of x. Okay, if I ask you what is f plus g of 7, it's f for 7 plus g of 7. It is not exactly like, oh, I'll just plug in 7 for x here. Most times that would work, but not all the time. For example, f and g of 0, they're nonsense. F plus g of 0 make no sense. So I just want to put back the answer here. F plus g of 0 makes no sense. And the reason why is, so just give me a second. The reason why is you cannot find f for 0. 1 over 2 times 0, 1 over 0, nonsense. That's nonsense. You can't find g of 0. Sure, you can square 0 and multiply it by 3. You can even multiply 4 by 0. And you can even add up those two results. You'll get 0. But you can't take away 1 over 2 times 0. This here is nonsense. But if you plug 0 in here, you'll get coincidentally 0. It didn't have to be 0. I could have said plus 7, so then I would have gotten 7. You don't look at the last piece. You don't look at the final thing. You look at the domain of f of x and g of x separately. And the domain of f is x x can't be 0. The domain of G is x cannot be 0. The domain of f plus G is both restrictions, which happen to be the same. So x cannot be 0. That is the domain of f plus G. You have to find the domain of f. You have to find the domain of G. Do not find the domain of f plus G. No, that's not how it works. Okay? Alright, so let us look at another problem. Suppose I tell you that f of x is equal to the square root of x minus 2, and g of x is equal to 4 over x minus 7, and we want to find the domain of f minus g. For the record, it wouldn't matter if it said find the domain of f plus g. So, the domain of f is what's under the radical has to be at least 0. That is, x has to be at least 2. And the domain of g is you can't divide by 0. X minus 7 cannot be 0. That means x cannot be 7. Now, since 7, if instead of 7 it said x can be negative 4, I would ignore this, because if x has to be bigger than 2, well then of course x can be negative 4. Can't be negative 4, it can't be negative 5, it can't be negative 5.8, it can't be negative pi. But if x is bigger than 2, that's including 7. So we have to say both. The domain is x is greater than 2 and x is not 7. It's all numbers 2 and above except 7. I can't find f minus g of numbers that aren't bigger than 2. No number bigger than 2 can I find f minus g of. I mean, what about f minus g of 1? Well, this is f of 1 minus g of 1. F of 1, well, 1 minus 2 is negative 1. You can't take the square root of negative 1. Maybe g of 1 I can figure out. I guess it's negative 2/3, I think. Okay, so it'll be the square root of negative 1 plus 2/3. But this is nonsense. You can't take the square root of negative 1. And if, like earlier, I had minus the square root of x, or plus the square root of x minus 2, when I subtract f minus g, this actually cancels out. You don't want to look at the final result. Okay, if you're going to look at the final result, you're leaving yourself open for errors. Do not look at the final result, please. Okay. What if I tell you that f of x is 1 over x, but g of x is x squared? And I ask you to find the domain of f times g and to find f times g itself. Well, for the record, if we find fg first, it's 1 over x times x squared, which is x. So you may say, oh, f times g is just x, so I can put any number in. No, you can't, because f of 0, so fg of 0 is equal to f for 0 times g of 0. F for 0 is 1 over 0. G of 0 is 0 squared. I don't know what that is. You can look for the domain after you combine the two functions. You have to look at the domain first. The domain of f. Oh, I can divide 1 by any number except 0. X cannot be 0. The domain of g. Oh, I can square any number. It's all real numbers. So the combined result is, now I don't care if you're looking for f times g, f plus g, f minus g. There's only one constraint. X cannot be 0. Do not look at the end result. Because if I had another function, h of x equal x, well then no problem. H of 0 is 0. This function and this function are not the same. This one's defined at 0. This one is not. Because I can take f for 0. I can take f for 0. They're different functions. Okay. Suppose I give you this function. These functions. F of x is equal to 1 over x plus 1. G of x is equal to x over x plus 1. And I want you to find two things. Find f plus g of x and the domain of f plus g. Well, if you add the functions, you get 1 over x plus 1 plus x over x plus 1. In addition, if the bottoms are the same, keep them the same. You get 1 plus x. Well, this is equal to 1 most times, and it's indeterminate other times. 0 over 0 is indeterminate. It's indeterminate when x is negative 1, because that makes the top and the bottom 0. And it's 1 if x is not negative 1. Okay. Now that's what we get. So we answered this. But the question is, did we really? You should always include the domain. What is the domain of f plus g? Well, you can add these two if one or both make no sense. You can't compute f of negative 1. You can't compute f of negative 1, because that makes the bottom 0. So I know that x can't be negative 1. Oh, look at that. You can't compute g of negative 1 either. That's the domain. X cannot be negative 1. Now, we are not getting the same answer. Here, right here, when I plug in negative 1, I get indeterminate. When I plug it in here for f plus g, I get undefined. I don't even know what rule to use. I don't even know what rule to use for f plus g. Okay, f plus g of -1, this is f of -1 plus g of -1. F of -1 is undefined. G of -1 is undefined. It is undefined. 0 over 0 is not undefined. 0 over 0, it can be 7, because 0 times 7 is 0. It can be 71. 0 times 71 is 0. It can be -711, because 0 times -711 is 0. But if you have 7 over 0, it's not defined. It's not 0, because 0 times 0 is not 7. It's not 10, because 0 times 10 is not 7. It isn't 7, because 0 times 7 is not 7. In fact, 0 times nothing is 7. This is said to be undefined. We're getting different answers. But more importantly, define the domain. Don't combine the functions. Look at them separately. Look at the domains separately. Okay, now we're going to talk about composite functions. Composite functions are hard enough, and then when you throw in the domains, it becomes even harder. But if you understand it, it becomes easier. Understanding math makes life easier. Composite functions. If you see f circle g of x, notice that's not a dot. This means f evaluated at g of x. F, G, X. Same order, F, G, X. If you are told that f of x is 2x plus 1, and g of x is 3x minus 2, and you're asked to find, this is typically called the fog function, fog of x, because f o g is fog. F circle g looks like the letters f o g, fog. Well, this is defined to be f of g of x. And I know what g of x is. They told me. It's 3x minus 2. So this is f of 3x minus 2. Now, what does f do to what you put in the brackets? If you can say it in words, you got it made. It doubles what's in the brackets, and then it adds 1. Whatever is inside the parentheses, it gets doubled, and then 1 is added to it. Okay, so I'm going to take what's in the brackets, I'm going to denote that I'm doubling it and adding 1. So I get 6x minus 4 plus 1. I get 6x minus 5. If you were asked to do it the other way, find the gof of x. Well, this means g of f of x. And they told us what f of x was. It's 2x plus 1. What does g do to what's in the brackets? Oh, it triples it and then deducts 2. Okay, whatever. Whatever in there, I'll denote that I'm tripling it and reducing it by 2. So I get 6x plus 3 minus the 2 at the end. You get 6x plus 1. There's no reason at all that you should get the same answer. There's no reason at all that you should get the same answer. Let us try another one. Suppose I tell you that f of x is equal to 1 over x minus 2, and g of x is 1 over x. And you're being asked to find the fog of x, the gof of x, and f circle f of x. And just for the record, we won't do this, but it doesn't just have to be 2 or 3. It can be f circle g, circle f, circle f, circle g of x. So first you would find f of g of x, get that answer, then you'd find f of that, so now you have this answer, then you'd find g of this answer, so you would have that, and then you'd find f of this. Okay, that made sense. Wonderful. Okay, so what is f circle g of x? Well, by definition, it's f of g of x, and g of x is 1 over x. Now, what does f do to what's in the brackets? Well, first, it puts a 1 on the top, and then in the bottom, it takes away 2 from what's in the brackets. Okay, 1 over x is in the brackets. I will take away 2. And there's one way of writing it. I can multiply the top by x, and then the bottom by x to kill off the x in that bottom. 1 over x minus 2, 1 times x. 1 over x times x is 1 minus 2x. Okay, that is the fog of x. What about the gof of x? What is g circle f of x? Well, it is g of f of x. F of x is that. It's 1 over x minus 2. And what does g do to what you put in the brackets? You can say one of two things. You can say it takes the reciprocal, which would give me x minus 2 over 1, which is x minus 2. Or you can say it puts a 1 on the top, there's the 1, and whatever is in the brackets goes in the denominator. And there's a rule that says instead of dividing 1 by that mess, you can multiply by its reciprocal, which is x minus 2. Let's not use x for times. To multiply by the reciprocal. See, either way, we get x minus 2. Okay, the last one is to find f circle f of x. Well, by definition, this is f of x. And what f of x is simple. We just read it off. It's 1 over x minus 2. Now, since I wrote on this a bit, let's erase it. And let us say in words what f does to what's in the brackets. Well, it puts a 1 on the top. It puts a division line. So that's what I'm doing now. And in the bottom, it takes away 2 from what's in the brackets. What's in the brackets is 1 over x minus 2. And I am going to take away 2. And then I'm going to multiply top and bottom by x minus 2. 1 times x minus 2 is x minus 2. 1 over x times x minus 2 is 1 minus 2x plus 4. 2x plus 4. And that's going to simplify out to x minus 2 over 1 plus 4, 5 minus 2x. But none of these answers are definitely correct. None of these answers are 100% correct. Because we didn't take into account the domains. Okay, let me write down the functions again, please. F of x is 1 over x minus 2, and g of x is 1 over x. Okay. What is the domain of the f function? We're dividing. Oh, we can't divide by 0. That is, x can't be 2, because 2 minus 2 would be 0. And the domain of the g function is, oh, it's a division. The bottom cannot be 0. That is, x cannot be 0. So now, what is the domain of the fog function? What is the domain of the fog function? Well, we're going to take f of g of x. What can we not take g of? 0. So we know that x cannot be 0. Okay. Now, we are taking f of what I underlined. What can you not take f of? You can't take f of 2. So g of x cannot be 2. Because I can't take f of 2. If g of x is 2, then I get 1 over x2 minus 2, which is 1 over 0, which is undefined. G of x cannot be 2. But I don't want to know what g of x can be. I want to know what x can be. Well, g of x is 1 over x. So 1 of x cannot be 2. Just take the reciprocal of both sides. X cannot be, remember, this is 2 over 1. So x cannot be 1 half. The domain of the fog function is x cannot be 0 and x cannot be 1 half. X can be any other number. Well, let's look at what we got for the fog function. We got this answer right there. Well, I know that the denominator can't be 0. Well, that's going to happen when 2x is 1. That's going to happen when x is a half. So x can't be a half. But wait a minute. We also know that x can't be 0. It doesn't say it over here. It doesn't say x can't be 0. Because 0 over 1 minus 2 times 0 is 0 over 1, which is 0. X cannot be 0. So we already know that x can be a half. So maybe we should also say x can't be 0. What about the Goff function? G circle f of x. Well, this is g of f of x. Okay, we're taking f of x. What can't you take f of? You can't take f of 2. So x cannot be 2. Now, what can't you take g of? You can't take g of 0. So f of x can't be 0. But fortunately, we don't have to worry. F of x is a fraction. And a fraction equals 0 only when the numerator is 0. That numerator is always 1. I guarantee you, we will never be taking g of 0. F of x is never 0. I mean, if you were to graph that function, it looks like this, where that's 2. It's never 0. It is never ever equal to 0. So you will not ever be taking g of 0. So this one never happens. So the only constraint for the Goff function is x can't be 2. But you know what? We don't have that here. We don't have that x can't be 2. You have to be careful. What about f circle f? F circle f of x. This is f of x. So I'm taking f of that. So it's x, so what can I take f of? I can take f of 2. But now I'm taking f of that. And what I'm taking f of can't be 2. But f of x is 1 over x minus 2. 1 over x minus 2 can't be 2. Taking reciprocals, I get that. Add 2 to both sides, I get x cannot be 2.5 or 5 halves. Okay, so x can't be 2, x can't be 5 halves. Well, the bottom is 0 at 5 halves. But what about x can't be 2? What about x can't be 2? So that's what I mean when I said earlier, we don't have the whole picture here. We can't use this rule when x is 2. We can't use g circle f of x. That is, we can't use that rule when x is 2. For the fog function, we can't use this rule when x is 0. Okay, the domain is not easily found. You have to look at what you're taking f and g of. Suppose you have f of x is the square root of x minus 2, and g of x is 1 over x. What is the domain of f circle g of x? So you need to take f of g of x. Oh, we have to take g of x. What can't we take g of? Well, what we're taking g of, we're calling x. So x cannot be, we can't take g of 0. So x can't be 0. Now we're taking f of this. So what can this be? What can't you take f of? Well, that's not just one value. You can only take f of values that are greater than or equal to 2. You can only take f of values that are 2 or more, because you need x minus 2 to be positive, or 0. That happens when x is 2 or more. So since I'm taking f from this has to be 2 or more. But I don't want to know what f of x has to be more than. I want to know what x has to be more than. So 1 over x has to be more than 2. Okay. That means that x has to be less than a half. Well, okay. So, okay, there are two cases. If x is greater than 0, I multiply both sides by x, and then I divide by 2. That is, x has to be less than 1/2. That's if x is bigger than 0. So, what we know is x is bigger than 0, less than a half. What if x is less than 0? And we still have this. So I multiply both sides by x, and I get that 1 is less than or equal to 2x. Because if x is less than 0, then x is negative. And if you multiply both sides by a negative value, you have to change the direction of the inequality sign. I divide both sides by 2, and I get that x is bigger than a half. And x is less than 0. This one has no solution. So x, for g of x to be bigger than or equal to 0, x has to be in here. Now, when I combine that with this restriction, I could ignore that restriction, because this one already says x can't be 0. So the x has to be bigger than 0. So the final answer is the domain of the FOG function is x can only be in between 0 and a half. It can equal a half, but not the number 2. Let's look at it the other way. F of x is the square root of x minus 2. And I think g of x was 1 over x. Yes. What about the Goff function? G circle f of x. So this is g of f of x. Well, I'm taking f for something. And whatever I take f of, it must be at least 2. So x is at least 2. Now, I'm taking g or something. I can't take g of 0. So what I'm taking g of, namely f of x, can't be 0. But like I said, we don't want to know what f of x can't be. We want to know what x can be, or what x can be. F of x is the square root of x minus 2. And it can't be 0. Well, it's only 0 when you take the square root of 0. And that only happens when x is 2. So when I combine these two, I get that the domain of the Goff function is x is bigger than 2. This says, oops, it can equal 2. This one says no way. No way. So it can equal 2. It has to be bigger than 2. This is hardball. This is not playing games. Whatever you do is, if you want, well, since that's in front of me, if you want to find the domain of the Goff of x, you do not find Goff of x. You do not find g of the square root of x minus 2. And g of anything is just the reciprocal. You do not find this. Okay? In this case, if you did, you would have lucked out. That would be the domain. The domain of this is implicitly that x has to be more than 2. Okay, because what's under the radical has to be greater than or equal to 0, which means x is at least 2, and what's in the denominator can't be 0. That happens when x is 2. Combining these two restrictions, we get x is bigger than 2. It is a coincidence. It's not always going to happen. To find the domain, to find the domain of the Goff function, do not compute g of f of x. Do not do that. If you want to find the domain of f plus g, do not compute f plus g. Don't do these things, because some problems areas could cancel out. One last one. If f of x is 1 over x, and g of x is also 1 over x, the domain for f is x cannot be 0. The domain for g is you can't divide by 0. X can't be 0. If you compute f circle g of x, that is f of g of x. G of x happens to be 1 over x. And f of x just takes the reciprocal. The reciprocal of that is x. Now, you may say, oh, f circle g of 0 is, 0. No, it's not true. Why is it not true? Because you can't look at the final answer of 0. You have to look at the intermediate steps. Can you find g of 0? The answer is no. If g of x is 1 over x, you can't find g of 0. It'll be 1 over 0, which is nonsense. And you can't find f of nonsense. That's further nonsense. That is, 0 is not in the domain. You can't find fog of 0. Do not go down to the final result and then do it. Now, if you want, you can go down to the final result, but you have to be careful. Fog of x. This is f of g of x. So, what can't you take g of? 0. Okay? What can't you take f of? 0. So, g of x can't be 0. But g of x is 1 over x, and 1 over x is never 0. So, this here will never happen. So, we only have that constraint. So, the domain of f circle g of x is not 0. Okay, so now, when we computed f circle g of x right here, and we set it equals to x, if we add on that x is not 0, because that's the domain, then we're okay. Because if somebody asked you what fog of 0 is, you would say, I don't know. It wasn't defined at 0. It wasn't defined at 0. It is undefined. Okay, so you can use the final answer as long as you write down the restriction on the domain. Or sometimes not the restriction. Maybe the domain is x is greater than or equal to 7, okay? That's not a restriction. It's not saying what x can't be. But then, if this is what f of x, if that is what fog of x is, fog of x is x, provided that x is at least 7, then fog of 0 is not defined. Only numbers 7 and above are defined for the fog function. Okay, I'm going to do one more problem. This is very important work. Suppose that I tell you f of x is 1 over x minus 2 and g of x is 3x minus 1. What is the domain of f circle g? Okay. So let us look at f circle g of x. This is f of g of x. And you can take g of anything. There's no restriction on which numbers you can triple and then take away 1 from. You'll never be dividing by 0. You'll never have a negative number under the square root sign. There's no trouble there. So that x can be anything. To take g of it, I can take g of anything. But now, I have to take f of this. I can't take f of 2. So, g of x cannot be 2. G of x cannot be 2. That is 3x minus 1 cannot be 2. That's going to mean that x can't be 1. Because if I add 1 to both sides, I get 3x cannot be 3. Divide by 3, x cannot be 1. Because g of 1 will equal 2. G of 1 will equal 2. It is 3 times 1 minus 1. It's 3 minus 1 is 2. G of 1 is 2. And I can take f of 2. Okay, so we have that the domain is x cannot be 1. Alright, so we have that. Now, what is fog of x? Well, it's f of g of x. And g of x is 3x minus 1. And what does f do? It takes away 2 from what's in there in the bottom. Puts a 1 on top, and it takes away 2 from what's inside in the bottom. So you have 3x minus 1 minus 2, which is 1 over 3x minus 3. Okay. Coincidentally, that has the same restriction. So you don't have to say it, because even if you did try to find fog of 1, you'd get 1 over 3 times 1 minus 3, which is 1 over 3 minus 3, which is 1 over 0, which is undefined. Okay, but it is possible that this could have not been that. It could have been 3x minus 3. Then you'd have to say x can't be 1. Okay, you have to find the domain before you can find fog of a number. Because if that number is negative, if that number is 1, you are in trouble. Let us end this video by doing it the other way. That is, what's the domain of the Goff function? What is the domain Goff function. Well, let's see what g of f of x is. Well, this is g of f of x. Well, what can't you take f of? Well, we're calling it x. So what can't you take f of? Ooh, you can't take f of 2. So x cannot be 2. Okay? What can you not take g of? I can take g of anything. F of x can be anything. It can even be 2. Let x be 2.5. F of 2.5 is 1 over 2.5 minus 2, which is 1 over a half, which is 2. Nobody says f for something can't be 2. You just can't take f of 2. I didn't take f of 2. I took f of 2.5. Okay. So, now that we know the domain, x cannot equal 2, is g of 1 over x minus 2. G triples what's in the brackets and takes away 1. So I am going to triple what's in the brackets and then take away 1. So I have 3 over x minus 2, take away 1. I'll write the 1 as x minus 2 over x minus 2. That way I have a common denominator and I get 5 minus x. Provided x is not 2. Okay? You can't always just blindly plug numbers in. Again, it's understood that x can't be 2, but I can make up problems all day long where in the composition the constraint goes away. Just let f of x be 1 over x plus 1 and g of x be 1 over x minus 1. The domain of f is x can't be negative 1. And the domain of g is x can't be 1. But that's not the domain. I want the domain of the fog of x. This is f of g of x. So what I'm taking g of can't be 1. And I'm taking g of x, so that can't be 1. But now, I am taking f of this. I am taking f of that. Not x, but g of x can't be negative 1. This can't be negative 1. 1 over x minus 1 cannot be negative 1. Well, I hope you see that if x is 0, you'd have 1 over negative 1, which is negative 1. If you don't see that, you take the reciprocals of the left side and the right side. The reciprocal of negative 1 is negative 1, so x is 0. X cannot be 0. When it comes to the fog function, you can't take the fog of negative of 1 or 0. But let us see what the fog function equals. And let's see if it lives up to that. This is f of g of x, which is 1 over x minus 1. What does f do to what's in the brackets? It does 1 over, 1 more than what's in the brackets. 1 more. That's 1 over x. Oh yeah, x can't be 0. But it can't be 1 either. You can't say the fog of x is 1 over x. Therefore, the fog of 1 is 1 over 1, which is 1. No. The fog of x is not 1 over x. It's 1 over x as long as x is not 1. Why don't I say x can't be 0? Because you're not going to get an answer anyways when you plug in 0. Okay? But the fog of x equals 1 over x is not correct. It equals 1 over x provided x is not 0. X is not 1, excuse me. So somebody asks you, okay, you know this, so what's fog of 1? You should say it's undefined. They didn't tell me what fog of x equals when x is 1. They told me what it equals when x is not 1, but they didn't tell me what it equals when x is 1. So it is undefined. Okay, that completes this video on composite functions as well as combining functions.